Good morning, ladies and gentlemen. My name is Chris Buerger. I'm here with Craig Griffin, who is a lead architect within Wind River. And we want to spend this morning and talk to you a little bit about our experiences in actually using the pre-release version of hydrogen in a scenario that combines a accelerated vSwitch, services chaining, on top of a Linux distribution that is traditionally used in a lot of telecommunications equipment. So let me just give you a little bit of my perspective on why we're here. And many of you have participated in a lot of these open source or Linux Foundation sponsored events, and it really comes down to 3 points. First of all, of course, we want to learn, and realizing that it's this session and lunch, and then we're standing in between you and lunch. I would encourage everybody to ask questions during the session because this is meant to be a bi-directional dialogue here. So if you have questions on our deployment scenario and roadmap, both or information on where ODL is going, we'd like to engage in that conversation. The specific point that we're really going to talk about is services chaining, and Craig is going to talk you through kind of an enterprise or even maybe service provider SDN scenario that we're instrumented with ODL, and then also some of the implications on the vSwitch. You've heard in the session before from Intel about some of the DPDK vSwitch options that exist in the marketplace, and we've actually been using one of those to implement our service chaining scenario. And then we also want to talk a little bit about the software ingredients that we used in the real world to implement that chaining scenario. Many of you are probably very familiar with the common Linux distributions like CentOS, Fedora. We took a little bit of a different approach using a Yocto project compatible Linux distribution simply because of our heritage in the telecom space, of being a provider of Linux and other operating systems to manufacturers of routers, switches, etc. And then talk about our experiences in using, again, pretty much the latest version of hydrogen. So that's why we're here today. Why Wind River? Actually, we have a little booth out there, and this was one of the most common questions that we got asked, so I just wanted to get this out of the way. We're 30-year, and our marketing team always likes to have this kind of slide. So we're a 30-year-old software company, about 2,000 people. We're also a subsidiary of Intel. So that's why you see a close cooperation between Wind River and a lot of the Intel software and hardware initiatives. We're really focused on embedded software. That's our heritage, and that's how we're looking at services chaining and ODL. Right? So high performance, very deterministic scenarios are kind of in our nature. And it's core to kind of the software ingredient choices that we're making. And we're also pretty engaged in open source, anything from the Linux Foundation's Yocto project, which is, again, for embedded Linux, to carrier-grade Linux specifications. Again, this is very core to what we think and do, to open virtualization Android. And then also you heard a project mentioned before, 01.org. There's a sub-project there on DPDK vSwitch, and we're very active there. All right, so let's spend a little bit of time in talking about just the core software ingredients that we used for the service chaining scenario, just as a foundation, or to give you an insight into the foundation and the choices that we made. So we started off with Yocto project compatible Linux. The Yocto project, again, is a cross-architecture Linux Foundation project that provides the tools and the methods for creating very efficient, very high-performance Linux distribution. And Wind River obviously has a distribution that's Yocto project compatible. So we used Wind River Linux as our base Linux distribution. As a company, we also launched a major initiative to enhance KVM last year, and we call this our Open Virtualization Profile. And this is really KVM on steroids. It's probably the best way to explain it. It's really KVM tuned to have almost real-time performance character. And we can achieve interrupt latency rates in the millisecond range, in the single-digit millisecond range, that are significantly, by an order of magnitude, lower than what you get with a standard kind of enterprise-class Linux distribution. We are using DPDK vSwitch as our vSwitching choice. We also have a lot of experience with the community version of OpenVSwitch. But as Brian from Intel was talking about before, the performance characteristics that we're seeing in the OpenVSwitch project right now is just don't make it suitable for a high-performance, near real-time kind of vSwitch. So we chose DPDK vSwitch for a number of reasons. And then we are chaining together a set of various virtual appliances. So we have a load balancer, we have an application delivery controller, a DPI engine from Cosmos, and then, of course, for the control element, we're using the hydrogen element. So those are kind of our software ingredients that we chose so far. And our objectives for using ODL were really simple, right? So we started a couple of months ago, and we just wanted to get going, like many of you probably are in the same boat, and we wanted to get going with a static service chaining scenario that is reflective of what you would see in a standard enterprise data center. We, as a second step, we wanted to perform a discovery and the capability negotiation with DPDK vSwitch through the OpenFlow and OVSDB interfaces. And this is where Craig is going to go into detail and talk a little bit about our experiences on what worked and what doesn't work and what we're still going to investigate in the future. We're also able to configure static flows through the interface, through the GUI, through the REST interface, and then start to monitor performance criteria. Going forward, one of the key things that's important to us is not just to emulate or to create a static service chaining scenarios, but also move it to the next step, which is service insertion and more of a dynamic scenario where you can add virtual appliances in real time or whenever you have a need to do that. Then there's certain validation work that we wanted to do, both on the DPDK vSwitch side and on the ODL side. And then everything that we do has a kind of a future outlook. And for us, one of the key future outlooks and directions is platform awareness, right? So the platform having awareness of its capacity, of its performance, and its capabilities, and then communicating that up to the SDN controller, for example. And again, Craig is going to talk a little bit more about that. All right. So now I'm going to hand it over to Craig, and he's going to start talking about the details of our services chaining scenario, what we did, why we did it, and what our experiences have been.
Great, thank you. So start off with this is a picture really of our test bed. It's where we're going to be learning from. Took a bunch of services, and some of these are it's really an artificial scenario. I mean, you're never going to put for instance, two IPsec gateways next to each other in a network. But we wanted to be able to learn things by connecting all these different types of virtual appliances together. Some of those, like IPsec gateway, are just a simple Linux IPsec implementation, but we've also tied into hardware crypto acceleration so we can get better throughput. Putting a load balancer in there, we can, and I don't show everything here, but we can have a number of different chains past that load balancer. And in our case, we'll have at least two virtual IPSs with WAN optimizers in series after that. So we'll build this chain, see what the issues are with how do you tie these together? How do you set up rules so that we can enforce policies and enforce the flow of packets between the various virtual machines? And overall, the flow we're going to have is coming in. We've got a traffic generator down at the bottom. We've got OpenDaylight running, really setting up the flows. And I think, as Chris mentioned earlier, statically setting them up at the moment. But the intent is to make that more dynamic. But packets would come into this chain, go through, and it'd be as if we're coming into an IPsec gateway, coming to another IPsec gateway. We're also using, in this case, what we call a K and I interfaces, the kernel network interfaces with DPDK. DPDK allows a lot of different, or several different interface choices, and we're trying to use all of them here, depending on what the capabilities of the appliances are. For instance, K and I is a higher performing interface than the QEMU VirtIO interface, so we're using that there. On the virtual load balancer, because that's really going to be a point where we're going to distribute from, and we want as high bandwidth as possible. We're going to run DPDK in the virtual machine, use what we call a IV shared memory interface with the DPDK vSwitch. We can get millions of packets per second through that VM, and then out of that, coming back into the vSwitch, and then we're going to chain that to another server and run some other additional pieces on there. And the first one there is we'd load balance to a couple of, as I mentioned before, a couple of different chains here. We could have multiple IPSs, and there's a lot of complexity in the flow on server B, and that's because we're doing several things there. And this is really in preparation for, as you go down, we're going to want to be able to much more dynamically control flows, control them in real time, react to traffic and decide, and there's a key part down here with this DPI engine. We want to be able to tell the appliances, give them some information about what kind of traffic, and in the future that could be heading towards services headers. Initially, we're going to use a DPI engine from Cosmos to actually classify flows and then put rules into the vSwitch, and we can do it at a much higher level than just a 12-tuple. We can look at the application and say, this application, for instance, is an application that I want a different treatment for in the IPS, and we're going to do that, and right now the plan is to just do that with a VLAN. We can send it on a different VLAN and say this is a different type of traffic at the application level, so we might have other flows that have different applications we don't want the special treatment for. The other thing we can do is say this is a traffic, and again this is about a policy part of it. We can say we want this type of traffic to totally bypass IPS, or maybe go to a different type of next step to get a different type of treatment so we can bypass. All this would happen, the flow would come into Cosmos as a default when it first starts up. When it recognizes that it's this application and we've set a policy against that, it then inserts into the vSwitch tables to now handle those packets at the application layer, not just with the 12 tuples. We're really actually extending somewhat the vSwitch capabilities there. And then we have WAN optimizers. Again, WAN optimizers come in pairs, so we're going to have everything from that point on would come, whether it came bypassed, whether it was getting special treatment through the IPS or just getting default treatment through the IPS, would come through a WAN optimizer, and then again through another server back out to there. And we're going to have a number of different types of traffic running through this. So we're going to have, and the intent is to be able to run all this type of traffic in parallel to exercise each of these pieces. For instance, WAN optimization or certain types of traffic that are optimized by the WAN optimizer and other types that aren't. We're going to have throughput through this. We're going to try to run as much and see what really, with the DPDK vSwitch, how much throughput we can pump through this specific scenario, knowing that there's going to be bottlenecks for different things. And like I said, the load balancer, we try to break that as a bottleneck by putting a very high performance interface on it. But we could find out that the IPS is a limiter. We could create more service chains downstream from the IPS so that we can get more parallel, and we could actually continue to grow this in terms of number of VMs and like I said, more parallel processing there. Or we can take, for instance, some of those interfaces, the VirtIO interfaces. Right now, those are third-party, so we're actually pulling third-party, not just not everything here is Windows Linux. We've got third-party IPS, third-party WAN optimizers. Work with them to get faster interfaces. Right now, they're using the standard VirtIO. They run fine on top of, for instance, on a just stock OVS too as well. But we'll want to get back to kind of the whole platform awareness is when can we get those interfaces in there, and then how do we provision those interfaces better or how do we know which ones to provision so we can take advantage of, if we have an application that take advantage of IV shared memory, we would do that. If we have one that can take advantage of KNI or can take advantage of vhost, which will be coming up from the DP to KV switch, we would do that. And also we've got the IPS manager down here is really more of a dashboard, being able to just look at, again, we're gonna run attacks to this. We can show simultaneously attacks, traffic like FTP, for instance, that we can do WAN optimization and essentially decrease the bandwidth that goes between those WAN connections. And we're going to have this whole demo system we can do that with. And be able to do things, change that configuration around, do things differently as we need to. But the big thing is this is our learning, initial learning configuration that we're going to really work with the vSwitch to figure out how can we make it work better in this scenario, and also work with ODL and make it grow into a much more dynamic configuration. I think I've hit everything on there. So as part of this, over the last month or so, is just getting ODL up and running with this configuration. Because DP2K vSwitch uses OVS as really front end, the actual experience of just getting it up and having it recognize the vSwitch was, that was 10 minutes of work roughly. But as we get into it, we found out other things, and I'll get into that. But and I think the UI, again, kind of a newbie bringing this up, it worked pretty well. I was able to see hosts. I was able to see the various. I could see the switch. I could see on this, and didn't have any issues with crashing. So it was very stable for me, and I was able to get by some of the stuff I was hoping I wouldn't have to deal with pretty easily. But then we could get in. Then we wanted to get into the things we're actually doing, and that's really. So the lessons learned are there, as well as on the next slide we'll have some of the things with DP2K vSwitch that didn't quite work the way we expect them to, and that's really what we're trying to find is where are the points that we need to work on these northbound interface, or not northbound, the southbound interfaces with the OpenFlow. And for initially, we focused only on OpenFlow, so OVSDB is something that is next to work on. So what we tried to do with this whole, I mentioned the static flows, is to just simply take a Python script, use the northbound interface, and set all those flows up in there, that whole chain. Limited example, I had to go out and I did find some examples, and really focusing on the flow the flow connector and the flow manager type functionality to program those flows. Found a few things about, learned things that if you don't put the rule in exactly right, they might show up on the GUI and they don't show up in the switch, or they show up in the switch with a drop action. So I had several cases of things like that, or I found something I know that works with the DP2K vSwitch, I know that works with OVS, but I could not figure out how to do some ARP commands because I was trying to really focus. And one of the key things with the service chain is to try to restrict the traffic only in those chains. I don't want anything else going between the gateway, the crypto gateway and the IP or the load balancer. I don't want anything else in there. I mean, you got to be really careful with some of this. Is that, and I found out from the IPS is that for instance, if ODL is sending LLDP packets in there and it goes through the IPS is going to forward those right through, and it's going to come right back to the controller. So I had to go learn a lot of that stuff to go figure out how to make this scenario work and really isolate these service chains. They're not generally connected to the network. They're actually we're forcing packets in. We don't want anything else in those. And as part of that too, we also go through and track through some of these issues I was having with ARP and with and initially with VLANs, which was more pilot error than issues with this was how do you go trace some of these things through ODL? How do you get the right packages and trace the packets through, enable the tracing, and deal with sometimes through these abstraction layers to follow. I was losing information along the way, needing to figure out where they were. So that was kind of an experience that we learned, and I actually learned quite a bit and was able to get to the point where I could even go modify some of them and do some debug that way. But again, kind of the initial learning curve to do all this was quite interesting. But in the end, we've got not that entire figure, but we've got a couple pieces of that working with ODL fairly smoothly. DPDK vSwitch. So one of the things we had, had to deal with, and I think Brian from Intel pointed this out in the previous session, was, there's a feature gap right now between what standard OVS does and what DPDK vSwitch. And actually, there's a little twist in there in that a little bit of false advertising on the part of the DPDK vSwitch was indicating it had capability when it was doing the feature negotiation capabilities. It was saying it was doing things it couldn't do. It was saying, like, I could modify in the 0.8 release. It said it could do, it could modify MAC addresses or IP addresses, and it can't do that yet. It actually can do that in 0.9. So little issues like that. That didn't cause this problem in the particular thing, but it's an example of the things that we're going to, as part of this validation of these interfaces, making sure that, and this is an ongoing effort to make sure that ODL and the OpenFlow plugins work with DPDK vSwitch, and if we need to modify the DPDK vSwitch, we will do that to make it negotiate correctly. For instance, in the false advertising case, and as DPDK vSwitch is continuously adding new features, like I said, there's another release out there that I'm not using. That'll be the next thing we bring in and make sure how that works with ODL. And another one, like port statistics, for instance, that's one of the areas we know that currently the vSwitch doesn't do. So when we look at on the ODL GUI, we look at that, we see 0 and 0 for all the port statistics, but the flow statistics work. So again, we want to keep closing that gap to be able to leverage that. Next steps is, again, get a better integration. We really want to get to a point where everything works perfectly between the DPDK vSwitch through the southbound interfaces, the OpenFlow interface, the OVSDB interface, in terms of functionality, in terms of the capability negotiations. Start looking at, how a little northbound is how this works with the OpenStack ML2 drivers as well, and make sure there's. Pardon me? How do you push flow to the DPDK? We're doing that through just a Python through the northbound interfaces, a Python script. We knew what the flows were ahead of time. We had a static configuration in terms of what VMs we had running. That's actually a down. So the Cosmos piece down here, the DPI engine down there, actually has some extensions to the tables, and there's some callback routines that you use in Cosmos, and from those we can go set those tables, and that just becomes part of the lookup when the vSwitch. So we actually have written, or we're actually writing. We haven't written this part yet, but they're actually writing the routines to handle, basically to tell it when you match something. We say matching an HTTP video application. We can say that, and then take this action. So there's just going to be a piece of code down in the Cosmos and a little routine, a user-written routine, not in Cosmos itself, but it provides the hooks for you to write your user-written routines. And we define, okay, if you see this, then we want that, insert that rule into the table. And that's happening locally on the vSwitch. That's not happening through ODL yet. One of the things we do, and I'll have it on, I think on the next slide, is how do you get that kind of information up to make it at a controller orchestration layer so you can make a decision from a global point of view versus from a local point of view. For instance, if I mentioned bypass as being a key thing here. If I want to bypass traffic, I can bypass it locally, but the right answer might be that I want to bypass that entire server, depending on where I've deployed my VMs. So that's the kind of decision you'd want to make at a controller level or higher. Adding more intelligence to the service chaining, really, how can we abstract? Like I said, this is very static right now. I know exactly where my VMs are. How can I make this? And this is, each of these virtual functions in the service chain have different needs, and especially when you're just picking them up, commercial version of it, they're going to have 1, 2, maybe management ports. They're going to have, typically single or pair or 4 data ports. So how can I abstract that and say I've got an IPS with 4 data ports and 2 management ports? And how do I bring, how do I just say, I want to deploy that on a machine, and it can go set up the correct types of interfaces, because it's not, you're not going to, how to say it, waste the capacity of an IV shared memory interface with DPDK for a management interface. So you actually would have different types of ports. We have it on different VMs in that picture before. You could have different types of interfaces, like the management interface getting a different type of port to the vSwitch. And also appliances affecting the flows. The Cosmos example was actually an example of that, where we can have the decisions. Also, the IPS could potentially say, again, I have a trusted flow, or I have a flow that I want to do something with. Go dump it somewhere. I want to redirect that flow because it represents a threat, or it's something I trust, and I want to redirect it somewhere else, and I don't want to, again, chew up all the bandwidth of the IPS processing flows that I already trust or I've already decided. Again, you can make those decisions locally, but the real answer in the long run is to get those decisions up to some sort of a policy management function that can make those decisions. And again, make them globally, and even possibly flow that out to other DPDK via switches or other IPSs in the system. Platform awareness, the key thing there's two parts of it actually. How do you get this information? I mentioned there's different types of ports, different types of usage of those ports for each of these virtual functions. How do you get that information up northbound somewhere so they can make a decision where to deploy this machine, what interfaces are available on that machine if IV shared memory is not an option, or even if it's not a DPDK vSwitch. I mean, this isn't meant to, the DPDK vSwitch won't be the only vSwitch, running in a data center, but how do you make sure that you make the right selection, of where you want to deploy a given virtual machine that if it needs to take advantage of a DPDK vSwitch, it does. So it's really this initial deployment. How do you make that decision? And then the next part is, how do you keep that information flowing up? How am I performing? Am I running out of bandwidth? What are my VMs taking a lot more bandwidth than I initially anticipated? Or CPU resources or anything? How do I get that information up and through these, the interfaces up to a controller, or more likely up to some sort of an orchestration, or again, like a policy manager that can make decisions to potentially move a virtual machine, move other virtual machines, warn someone that we're about to violate a service level agreement. And that's really important. A lot of our customers are really concerned about being able to deploy and monitor, set it up so it's going to meet the service level agreements, and if it doesn't, they need to know so they can take actions. And whether those actions are automated or manual right now, the key thing there is the awareness. Management plane, I brought that up. Again, I mentioned a second ago about the management plane being a lot of these appliances have their own management interfaces, and they have special needs there too. I mean, they might just generic management interface, but it needs connectivity to their management platform. There's also other management interfaces, or I lump them under the management plane for high availability. For instance, a lot of physical appliances will have direct physical connection, which is the ultimate arbiter of whether which one of these is actually running active. One of them is running passive. So how do I make sure that that's a very reliable interface, and then also how do I make sure that how do I redirect traffic if I need to, in the case of if there is a failover or some sort of decision between those two virtual machines on where to go. I think that's about all I had.
Craig, please stay here.
I will. I will.
We've taken our first step on a journey, and as a company, we're committed to using ODL, almost like test driving it in increasingly complex service chaining scenarios that reflect what our customers are actually building in the real world. But in terms of the call to action, mirroring what Uri and Brian were talking about before, there are a lot of vSwitches out there, but there's really just one major implementation, one major open source community around a DPDK accelerated vSwitch. So I'd like to encourage all of you to go to 01.org and to check it out. We've been, over the last year since the project started, we've grown members from the double digits to the triple digits now, more, getting into the thousands now of people that have downloaded it, have tried it, and engaging with it, and are contributing with it, and you'll certainly see Wind River there as well. And as I was saying before at the beginning, there's a couple of areas, or our angle, as I think Craig from SDN Central was talking about. For us, our angle is really around services chaining with ODL. And making that migration from very simplistic, static use cases to something that is very dynamic, where you can insert services and virtual machines on an as needed basis, also as the capabilities of the network and the hardware are changing. That's really what we're planning to focus on within ODL. And then longer term, together with our mother company, Intel, platform awareness is really important, right? If you have an Atom processor versus a Xeon processor, capabilities vary, right? How many cores you can run, whether the cores are being starved by certain applications running on the virtual machine. That makes an impact on how you dynamically manage your SDN network. And again, this is an area where you will see Wind River together with Intel innovating and providing technology and solutions. All right, as I was said before, we're standing between you and lunch. So I want to open it up to everybody to ask some questions.
I think one thing mentioned too is that we want to get from people here is what are the requirements that they see in terms of that, and also what are we doing within ODL community and other communities to really make service chaining work in this scenario. Like I said, it's not all around how DP2K vSwitch works, but how does service chaining work? And best practices. And like I said, we're not going to invent everything. We're looking really to work with the community to understand and to implement some of those.
Okay. Good. Question? So the question is there's earlier, I think it was actually Uri that said that services chaining is a little bit of a tainted word. To be honest with you, I think you have to ask Uri from Intel. From my perspective, services chaining is a reality. It's one of the promises of SDN that you can take physical appliances that you put together in the chain before and just virtualize them. So to me, services chaining as a concept is nothing new. What is new is that within SDN you can do it in a virtual environment. So I actually personally don't have any negative association with that term, and you see it on the slide here. So
right.
I don't know. Question there from the back. Right. Great question. Yep. So, Craig, why don't you quickly repeat the question because it was pretty complex, and then maybe provide your thoughts as well.
Okay. So I guess what I understood the question is around what have we looked at and with respect to things like hairpinning of traffic and tromboning so that your traffic's not coming back in and out. And actually we've had a discussion early on this and with the way that some of the traffic flows right now, we're almost enforcing a serial and not coming back. But when you come back through, for instance, if you have you've got to somehow differentiate traffic coming back in, especially if you're not modifying the packets along the way. And that's kind of one of the things in the future that I think the services header type work is meant to prevent, right? So that you can at least differentiate, and if you have situations, you can differentiate coming back into a virtual machine, or sorry, into a server and into a vSwitch, that this is the second time the packet's been there, and I don't want to send it like I did before to that VM. But we haven't gone really deep into figuring out how to do that right now. Right now, very much in our figures, we're worrying more about trying to avoid. I don't want to say trying to avoid that issue, but we're not implementing that situation in here. But as you start to implement these, scheduling of these appliances all over the place, you're going to hit that, right? You're going to have for some reason or another, someone might make a decision to deploy, in our case, the crypto gateway on one machine, the load balancer on the next, and it load balances it right back to the same machine with an IPS running on that same machine. And we definitely have to, really worry about how do we make that traffic differentiate? How do we either encapsulate it differently so when it comes back, we know it can only go to that flow, which might simplistically initially just be put it on a different VLAN. Right. But in the future, I think, again, this whole idea of passing information, additional information and metadata back so that you can make better decisions with that packet, and you can identify at any stage that it's point X in the flow, right, in the service chain. It's the third. It might be the exact same packet except for the fact that somehow it indicates that it's the third entity in the chain versus the fifth.
Yeah. And we did run into one situation with LLDP that you talked about before.
Yeah. But that was more with ODL. Yeah, we had to keep ODL from sending packets through especially these just bump in the wire type appliances are the worst because they're not doing anything to the packet. A load balancer, we have an IP address coming in, it's a different IP address coming out. It's very easy to classify. A bump in the wire is somehow we've got, and we have to address that. How do you make sure appliances like that don't cause problems?
Yeah. Okay. All right. Any other questions? All right. Mm-hmm.
Right. So you're asking if layer 2, layer 3, layer 4 appliances are applicable, and we're trying to address all those, and we are in that diagram. We had a layer 2, essentially a layer 2 forwarding function, a WAN optimization, which is working at layer 3, the IPS, which is doing things at layer 3, even expecting deeper at application level. But to the network, it's looking like a bump in the wire. It's not even, it's not modifying the packets at all. So yeah, really, how do you make those coexist and be able to chain them together in the way that you need to chain them together? As a user, I want to do that. I want to put this in front, or I need to do this function first because that's where it's coming in off, from the external network. But I could have even a number of different IPS firewall type appliances in series and have them go through. I might have my own particular order based on, I might not want to do, for instance, pattern matching type of things on every single packet. I might have other VMs in front of that take care of really filtering out, right? So that only the traffic, the minimum amount of things that I need to do pattern matching goes to that VM. Yep. But the ordering has to be there, and whether like I said, whether it's layer bump in the wire, layer 2 forwarding, layer 3, or higher like with a DPI being able to go higher, we need to be able to handle this. Mm-hmm. Yep. Mm-hmm. Right. Yeah, well, we'll know. We're going to know ahead of time that that, for instance, the front end virtual IP on a load balancer is getting the traffic to the load balancer. Coming out of it, it's going to be on another subnet or another basically another subnet to the back end servers. So we'll have to know. We're going to know the IP addresses of the servers and be able to give each one of the flows to each one of those back end servers or load balance, or not necessarily servers, or in our case IPSs that we're going to load balance to. So we'll have to, so we're going to, at the level of setting all this up, we're going to know on both sides of that load balancer what the characteristics that we need to write flows against, and Like actually that was fairly easy. I've done that as well. You know, to implement that was fairly easy. It's actually harder when the packet doesn't change at all. To be able to avoid, I think, the kind of the hairpinning or tromboning type effect.
Okay, one more question in the back.
This question is kind of related. When you say service chaining, are you talking about services only provided by functions running in the VM, or also services provided by the vSwitch as well? Because I think there's different models where SDN layer,
Let me get back to the presentation.
providing connectivity,
Mm-hmm.
and something providing a service. When if you look at the pure SDN model, you could have the vSwitch and SDN, the intelligence decentralized,
Right.
providing a service directly on at your vSwitch or physical switch layer.
Right.
So when you say service chaining, is the vSwitch part of that service or only providing connectivity?
Beyond doing, I mean, it's and you can think of what we're doing with the deep packet inspection as being somewhat of a service inside of there, that we're actually doing an additional layer of classification and enforcement of things that is not part of the normal vSwitch. It's very tightly integrated with the vSwitch. That's the only thing on that figure that's not, I would consider a virtual appliance, right? That is part of, or integrated with the vSwitch. I don't know whether applications can fall into that category right now, but I don't think there's anything preventing that as we see other opportunities to implement functionality that makes sense to better implement down with the vSwitch than in an appliance. Because like I said, if you could, and this is absolutely trivial to do, take that DPI and you could run it up in a virtual machine as well. But there's probably other appliances we can do that as well. Crypto might be one example of that. You could run crypto acceleration down closer to the vSwitch and not have to go up through a VM to do that.
Yep. So to give you a short answer, it's really both, right? And as DPDK vSwitch evolves, right? So one of the thoughts right now is to expand the framework or create a little bit of a framework for these kind of engines to plug into it directly and then make decisions locally on the vSwitch as part of a services chain. All right. That's like two questions.
I see that it's more of virtual appliances,
Right.
right? So but really, if you look at network operators, what they have today is more of a physical
Yes.
hardware appliance.
Sure.
So perhaps a nice thing to do would be to kind of have a transition plan, indicate how we service chain of a physical hardware appliance with virtual appliance.
Absolutely, and that's really part of our actually joint project with Intel as well, right? There's both physical, switches, enterprise class switches that may have capabilities such as 802.1aq, right, SPB, and that now have to extend into a vSwitch world, right? How do you do that in a services chain? Just a stand. Okay, so let's talk a little bit more about that. So that's great. And we had a question up front, and then I can get to you. Okay.
The question I had is, you have one physical box that you virtualize into 10 VMs.
Right.
There is a management aspect to it where suddenly there's a burst number of service VMs that's coming to the picture. So how are we going to manage it? So there's a version management.
Right. Right. And that's a great question, right? I mean, from a control perspective, right, our OpenDaylight is our SDN controller, and that has certain capabilities. Each of the VMs has its own management interfaces, right? And then there's also all the northbound APIs, OpenStack, et cetera. And at the moment, it's actually, I would say, it's kind of messy.
Yeah.
There's
Yeah, we're looking at potentially, like for instance, the IPS manager. I mean, each of these appliances, because like I said, they can come from different places. These are different vendors. The IPS manager is specific to one of the vendors. There could be another one, at least access to or a management application for a WAN optimizer or a gateway, right? And so you could have a lot of these managers. Do you end up moving some of that stuff together and try to consolidate that, or do you leave those all separate so you always have this, this IPS manager entity in the network as well? Or do you try to consolidate some of that, or maybe they work with, and this is another concept of working with, like with OpenStack and having those managers integrate with OpenStack, so at least everything's coming through the same infrastructure.
So one way
way to think about is really map it to a hybrid SDN model,
Right.
Where you just leave the distributed elements access to it,
Yeah.
and just add the service chaining variable to the top. Essentially, just programming flows are basically just leave
Right.
things as today. But
Yeah.
it needs to be expanded, of course.
Yeah, I know.
Yep.
But it's as an administrator, it will become an issue because you're so used to check your IPS, for certain types of attack traffics and how the behavior was of the IPS, and it's not a single pane of glass concept right now.
And some of these ones, like the IPS manager, I mean, they can make decisions for their right now. This way this is deployed, they can make a decision, that affects, and they can tell their IPS is something, flow down, a 0-hour attack information or something or it's detected, or tell one of their appliances to shut down. But what they really need to do is, again, work within the entire framework so that if they see a problem, they can take action at the network level to, like I said, reroute traffic, create another place I can go send traffic, I'm running out of capacity, I can go work with OpenStack and say, deploy 10 more of these appliances and configure them and set them up and automatically do all that.
Good. All right, one more last question.
What's the relation between OpenDaylight Switch and DPDK switch? Are you just replacing the way the packets go traffic from user to kernel, or are you doing something else?
So actually, you probably missed that presentation from Intel. Since we have Brian in the audience, I think it's probably easiest if you want to provide like a 30-second summary of the delta between DPDK vSwitch and the community Nicira Open vSwitch. Yeah.
So what we did in what's available now in 01.org was to take the control even the same and accelerated the data plane, so we have a DPIF for the data plane, to do all of that in using our DPDK with strings and libraries, that whole set of structures and capabilities we've had for a few years to develop. So for example, the full-on driver would be one example. Now, are you asking specifically about feature gaps? So, we don't support, it's not fully featured. I mean, one example might be VXLAN, right? We don't support VXLAN in that today. Now, that's where, we're continuing to evolve the features that are available through that vSwitch. And then in the talk that I gave about an hour ago, we talked also about some work we're doing about bringing DPDK into the OpenVSwitch.org version as well. So there's kind of both efforts ongoing. That second one I just mentioned just happened and is very, very early days. It doesn't have anywhere near the performance that you get the architecture these guys are talking about.
Yeah. So we've done actually some comparative testing between the community, the Nicira OVS project, and the DPDK vSwitch, and for small packet sizes, we get seeing like a 10x performance difference. And we have a little bit of a demo of that in our booth as well, if you want to come and check it out. Good. I think we're definitely out of time, so I'm just going to say bon appetit to everybody, and thank you very much for attending. Insight into the foundation and the choices that we made. So we started off with Yocto project compatible Linux. The Yocto project, again, is a cross-architecture Linux Foundation project that provides the tools and the methods for creating very efficient, very high-performant Linux distribution. And Wind River obviously has a distribution that's Yocto project compatible. So we used Wind River Linux as our base Linux distribution. As a company, we also launched a major initiative to enhance KVM last year, and we call this our Open Virtualization Profile. And this is really KVM on steroids. It's probably the best way to explain it. It's really KVM tuned to have almost real-time performance character. And we can achieve interrupt latency rates in the millisecond range, in the single-digit millisecond range, that are significantly by an order of magnitude lower than what you get with a standard kind of enterprise class Linux distribution. We are using DPDK vSwitch as our vSwitching choice. We also have a lot of experience with the community version of Open vSwitch. But as Brian from Intel was talking about before, the performance characteristics that we're seeing in the Open vSwitch project right now is just don't make it suitable for a high performance, near real-time kind of vSwitch. So we chose DPDK vSwitch for a number of reasons. And then we are chaining together a set of various virtual appliances. So we have a load balancer, we have an application delivery controller, a DPI engine from Cosmos, and then, of course, for the control element, we're using the hydrogen element. So those are kind of our software ingredients that we chose so far. And our objectives for using ODL were really simple, right? So we started a couple of months ago, and we just wanted to get going, like many of you probably are in the same boat, and we wanted to get going with a static service chaining scenario that is reflective of what you would see in a standard enterprise data center. We, as a second step, we wanted to perform a discover both information on where ODL is going. We'd like to engage in that conversation. The specific point that we're really going to talk about is services chaining, and Craig is going to talk you through kind of an enterprise or even maybe service provider SDN scenario that we're instrumented with ODL, and then also some of the implications on the vSwitch. You've heard in the session before from Intel about some of the DPDK vSwitch options that exist in the marketplace, and we've actually been using one of those to implement our service chaining scenario. And then we also want to talk a little bit about the software ingredients that we used in the real world to implement that chaining scenario. Many of you are probably very familiar with the common Linux distributions like CentOS, Fedora. We took a little bit of a different approach using a Yocto project compatible Linux distribution simply because of our heritage in the telecom space, of being a provider of Linux and other operating systems to manufacturers of routers, switches, etc. And then talk about our experiences in using, again, pretty much the latest version of hydrogen. So that's why we're here today. Why Wind River? Actually, we have a little booth out there, and this was one of the most common questions that we got asked, so I just wanted to get this out of the way. You know, we're 30-year, and our marketing team always likes to have this kind of slide. So we're a 30-year-old software company, about 2,000 people. We're also a subsidiary of Intel. So that's why you see a close cooperation between Wind River and a lot of the Intel software and hardware initiatives. We're really focused on embedded software. That's our heritage, and that's how we're looking at services chaining and ODL, right? So high performance, very deterministic scenarios are kind of in our nature. And it's core to kind of the software ingredient choices that we're making. And we're also pretty engaged in open source, anything from the Linux Foundation's Yocto project, which is, again, for embedded Linux, to carrier-grade Linux specifications. Again, this is very core to what we think and do, to open virtualization Android. And then also you heard a project mentioned before, 01.org. There's a sub-project there on DPDK vSwitch, and we're very active there. All right, so let's spend a little bit of time in talking about just the core software ingredients that we used for the service chaining scenario, just as a foundation, or to give you an Good morning, ladies and gentlemen. My name is Buerger. I'm here with Craig Griffin, who is a lead architect within Wind River. And we want to spend this morning and talk to you a little bit about our experiences in actually using the pre-release version of Hydrogen in a scenario that combines a accelerated vSwitch, services chaining, on top of a Linux distribution that is traditionally used in a lot of telecommunications equipment. So let me just give you a little bit of my perspective on why we're here. And many of you have participated in a lot of these open source or Linux Foundation sponsored events, and it really comes down to 3 points. First of all, of course, we want to learn, and realizing that it's this session and lunch, and that we're standing in between you and lunch, I would encourage everybody to ask questions during the session, because this is meant to be a bi-directional dialogue here. So if you have questions on our deployment scenario and roadmap,